Okay, this is a problem on how to prepare a buffer. So the question is how many moles of NH4Cl must be added to 2.0 liters of 0.1 molar of NH3 to form a buffer whose pH is 9.00. So first of all, we here can identify the NH3, that is the base, and NH4Cl, that is the conjugated acid. So we know that for a buffer we almost use like a weak acid, a weak base. So we're talking about an equilibrium. Okay, so we start with NH3 plus, this is in water. Okay, NH3 is a base, so this will produce OH plus NH4. In this case, water is going to act as an acid, and the NH3 is a base, so water is going to give a hydrogen to NH3 to form NH4, and here we have the NH3 that is the base and NH4 the conjugated base. The conjugated acid, sorry. So, because we're talking about an equilibrium, we need to talk about a dissociation constant, and this is a base, so we must talk about a Kb. Kb is going to be equal to the concentration of OH minus times the concentration of NH4 plus divided by the concentration of NH3. So we need to calculate the concentration of NH4Cl. So by using this equation of Kb, we can determine the concentration of NH4. So NH4 plus the concentration of this is going to be equal to Kb times the concentration of NH3 divided by the concentration of OH. And the value for Kb is going to be equal to 1.8 times 10 power of minus 5. That's Kb. So we need the value of Kb, we need the concentration of NH3 and the concentration of OH. So we have Kb, the concentration of NH3 is 0.1 molar of NH3, and we need the concentration of OH. So where can we find the concentration of OH? In the pOH. So we know that, for example, pH plus pOH is equal to 14. So pOH is going to be equal to 14 minus the pH. So pOH will be equal to 14 minus 9. This is the pOH. So the pOH is going to be equal to 5. So that means that the pOH is 5. The concentration of OH is going to be equal to 1.0 times 10 powers minus 5 molar. Remember, that is the antilog, so it will be 10 minus 5 of the pOH. Okay, so here we have the concentration of OH, we have the concentration of NH3, and we have the concentration of, the Kb value. So that means that we can now substitute all this value and say that NH4 plus is going to be equal to Kb. Kb was 1.8, so this will be 1.8 times 10 power of minus 5. This will be multiplied by the concentration of NH3, that was 0.10 molar, and divided by the concentration of OH, that is 1.0 times 10 minus 5 molar. So the concentration of NH4 is going to be equal to 0.18 molar. This is the concentration of NH4 plus. And now remember that molarity is equal to moles over volume. So if we multiply the concentration, the moles of NH4Cl will be equal to the concentration of NaCl times the volume, that is 2.0 liters, and this will be equal to 0.36 moles of NH4Cl. And if we multiply this by the molecular weight of NH4Cl, we determine how many grams we need to add to the solution to prepare this buffer.